Yeah, yeah. Good morning.
Good morning, sir.
Okay. So we will start the class within 1 minute. Okay. Yeah, can you view the PDF I have shared on the screen? Hello, yeah.
Yes, sir.
Okay. So can you view the PDF I have shared on the screen? Is it visible?
I'm trying to look for it.
Engineering Graphics Class 11, the PDF I have shared. Is my screen visible? Screen.
Yes, sir.
Now what is
Yes,
showing?
sir.
Whiteboard.
No, it's showing Engineering Graphics Class 11.
Yeah, same. Yeah, okay. Okay, so today uh, we are going to do some drawings in sections. Okay. So sections of solids. Yeah. Okay. So see, what is the name of this view? Yeah, here. What is the name of this view?
Top view.
No, the left side, this one, this is actually 3D view, right? 3D view, right? Three-dimensional view, right? 3D.
Yes, sir.
Okay, because all the three dimensions are there. Okay, so length, breadth, and height. All the three dimensions are there. So that is called a 3D view, or it is also known as pictorial view, or it is known as isometric. Okay, so 3D view or pictorial view or isometric view, all are same. Okay, because three dimensions are there: length, breadth, and height. Okay, so in the right side you can see two views. What is the name of this view above XY line?
Front view.
Front view or elevation. Okay, front view or elevation. This is called the front view or elevation. Below XY line, what is the name? This one,
Top top view.
top view, or it is, or the other name of top
Plan.
view, plan. Okay, plan. Okay, so this view is also known as orthographic views. Orthographic. Okay, so orthographic view means 2D view. 2D, because front view front view you can see how many dimensions are there. Front view, how many dimensions? Front view. Front view.
Yes. Height.
Front view, only two dimensions, right? Only two dimensions, right?
Yes, sir.
Okay. So it is a 2D view, two-dimensional view. Similarly, top view also check how many dimensions are there. Two dimensions, right? Two dimensions. So it is known as 2D view. So orthographic view, orthographic view is also known as 2D view. 2D view. Okay. Isometric view is known as 3D view. Is that clear? Isometric versus orthographic, clear?
Yes, sir.
Okay. Then, okay. So this is called a section. Okay. Here, the first figure. Can you say something about the first figure? Yeah, here. The first figure.
The section plane
Yeah.
is perpendicular to HP.
Yes. Okay. So this is called a section plane. Okay. So this is called a section plane, or it is known as cutting plane. Okay. Section plane or cutting plane. Section plane or cutting plane. Section plane or cutting plane, because we are using this plane to cut the object. Okay, here the cutting plane. Yes, tell me what is the condition here. Here the cutting plane is, here the cutting plane.
Perpendicular to HP.
Yes, here the cutting plane is perpendicular to HP and parallel
And
to,
parallel to VP.
yes, and parallel to VP. Okay, very good. Okay, so that is the okay. So the cut here, the cutting plane is, here the cutting plane is parallel to VP and perpendicular to HP. Okay. Then what about the this figure, second figure? What is, can you say something about the second figure?
It's cut.
It's cut into two pieces, right?
Yes.
Yeah, okay. Then any other thing?
Um,
What is called a section? What is called a section?
the part that's made by the section plane,
Yeah,
the
that
inside part.
yeah, that area, that cut area, that is called a section, right? Then
Yeah.
what is called a hatching? Hatching, Hatching, hatching.
The 45-degree lines that show a section.
Yeah, the 45-degree inclined lines that shows this section. Okay, that is called a hatching, and this lines are called hatching lines. Okay, this lines are called hatching lines. Okay, so this is called a section, and we are representing. We are using this 45-degree inclined lines for representing the section. This is called very important hatching. This is very important. Hatching, hatching. Okay, and we are for hatching we are using the 45-degree inclined lines. 45-degree inclined lines. 45-degree inclined lines with the uniform spacing. With uniform spacing between them. With uniform spacing with uniform spacing between them okay, then here you can see a view. Okay, what is this? The third figure. What is the third figure?
It's the top view and front view.
Yeah, the third the third drawings, 2D view or 3D view?
A
Third
2D view.
2D view. Okay, so it is also known as orthographic view, right? Orthographic view. Orthographic view. Okay, so this in the front view. In the front view, here you can see some lines, 45-degree inclined lines. What is that?
The hatching
Yeah, hatching
lines.
means that represents the section. So this is the front view, and this section is represented here, right? This is the section, and here in the in the center, not center, in the right side you can see an area that is not hatched. Why? Why that area is not hatched?
Because it's
Because
not part of the section.
yeah, because the cutting plane, because the cutting plane is not cuts that portion, because that is a hole, right? Because that is a hole. No area, the cutting plane is not touching that cut any portion there. That's why there is no hatching line there. Okay, so this is also very important. Okay, then what about the top view? What about the top view? Say something about top view.
Um, the cutting plane is in the middle.
Yeah, what is that AA? What is that AA?
The cutting plane.
Yes, okay. The cutting plane, the naming of the cutting plane is AA, like that. AA or BB, like that. CC, like that. Okay. What about the ends of that line? Is it thick or thin?
It's thick.
Thick. Okay, very important. Okay, very important. So the cutting plane representation in engineering graphics is like this: a chain line with ends thick. Chain line with ends thick. Okay, clear? This section plane and its representations clear?
Yes, sir.
Okay, so very important. Okay, so here the important terms are section, hatching. Hatching is very important. Hatching, then cutting plane representation, very important. Cutting plane representation, then the hatched lines, the 45-degree inclined lines, hatching lines, very important. Okay, and the section plane, the location of the section plane, very important. orthographic view, isometric view. Then what is the difference between orthographic view and isometric view? 2D view, 3D view, pictorial view. Okay, so clear. Then the next one. Yes, sir. Yeah, here. Tell me something about this one. The first figure. Yes, this one.
It's a cylinder,
Yes, cylinder. Okay, correct. Then
and it's been cut with a cutting plane parallel to HP
cutting plane parallel to HP. Correct. Okay.
and perpendicular to VP.
Perpendicular to VP. Correct. Okay.
And
Cutting plane is at a distance of say X millimeter from the top, right?
yes, sir.
Okay. What about the section? What about the section? What is the shape of the
It's a
section? Shape of the
circle,
section.
a circle.
Circle. Okay, right. What is this? What is this inclined lines?
The hatching lines.
Hatching lines. Okay. What about the angle? 45-degree, right?
45 degrees.
And what about the spacing? What about the spacing between the lines?
It's small.
Uniform spacing. Small and uniform. Okay, uniform spacing between. Okay. Okay. Then the second one. Say something about the second one.
It's a hollow square prism,
Okay.
and it's cut by a cutting plane parallel to HP and perpendicular to VP.
Okay.
And the cutting plane is below the top side.
Yes. Okay. What is the name of that cutting plane?
Uh, BB.
Okay. Correct. Okay. So then third one.
It's a hollow cylinder.
Okay.
The cutting plane parallel to HP and perpendicular to VP.
Okay.
Um, and it's below the top side.
Okay. So here, what about the section?
It's
Why there is no section lines in
because
that that central circle? Why there is no section
that
lines?
is a hole.
Hole. Okay. Right. Okay. Then the fourth one.
Um, it's a hexagon pyramid, a hexagonal prism,
Prism. Okay.
with a cutting plane parallel to HP and perpendicular to VP below its top side.
Yes. Correct. Okay. Okay. Clear. So the concept is clear. So very good. Okay. So sorry. Okay, so this is very important. We already discussed this, so I will repeat the same thing again. Okay, no problem. So this is the pictorial view of a square pyramid with the section plane. Okay, so this is my horizontal plane. and this is my vertical plane, right? Here the object is a square pyramid. So this is my square pyramid. So this is my square pyramid. And here what is the, here tell me, say something about the cutting plane. Yeah, here, here the cutting plane position.
It's parallel to HP and perpendicular to VP.
Yes, the cutting plane is parallel to HP and perpendicular to VP, right? Okay, so this is my cutting plane, and when I use this cutting plane, here you can see the top portion. Okay, this portion is removed. This top portion is removed. This top portion is removed, and the bottom. This is the remaining. This is the remaining portion. Okay, so this is the remaining portion, and this area, this is called my section, and we are using 45-degree lines for representing the section. So here, tell me here, what is the top view? Here, what is the top view? Here, what is the
The
top
top,
view? Hmm?
top view is a square pyramid
Okay,
with a square section on top.
okay. Top view is a square, is a big square and a small square, right? Top view, right?
Yes,
Okay,
sir.
okay. Then what is the front view? What is the front view? Front view is a trapezium, right? Front view is a trapezium, right?
Yeah.
Okay, clear. I will clear this. Okay. Yes. Okay, yeah, here. Say something about this figure. The first figure, this one.
The cutting plane is parallel to VP and perpendicular to HP.
Okay. Then this one, second one, same thing, right? Cutting plane is
Yeah.
parallel to VP and perpendicular to HP, right?
Yes, sir.
Okay. Third one.
Um, it's perpendicular to HP and
And inclined to VP, right?
yes, sir.
Okay, so here this case is the cutting plane is perpendicular to HP. That means this inclination, this is 90-degree perpendicular to HP and inclined to VP. So this is inclined to VP, inclined to VP. Okay, so cutting plane is perpendicular to HP and inclined to VP. In the previous case, in this case, cutting plane is perpendicular to HP. That means this angle is 90-degree perpendicular to HP and parallel to VP. Okay, then next one. Okay, what about this? What about this figure? The first one, this one, the first one.
It's parallel to HP and perpendicular to VP.
Yes, cutting plane is parallel to HP and perpendicular to VP. What about this figure? Second figure.
It's parallel to, I mean, it's inclined to HB and perpendicular to VP.
Yes, okay. So cutting plane is this is inclined to HP. So cutting plane inclined to HP, cutting plane inclined to HP, and this is perpendicular to VP. Perpendicular to VP means 90-degree to VP. Okay. So this is another type of problems. Okay. Then next is this cube problem. Okay, so write the first question. Okay, write this question. Write this question. Cube. A cube of 40 mm side. Okay, cube. Okay, so this is my cube, right? Okay, so cube of 40 mm side. So side is 40. What about if the side is 40? What is the height of the cube?
Mm, the side is 40.
If the side is 40, so what is the height? Height of the cube?
40.
40. So side is equal to height. Okay, side is equal to height. Is cut by a horizontal section plane. Horizontal section plane. Very important. Horizontal section plane. So what is a horizontal section plane? Horizontal section plane means section plane parallel to HP. Section plane parallel to HP and perpendicular to VP. And perpendicular to VP. Section plane parallel to HP and perpendicular to VP. That is called a horizontal section plane. Very important. This term is very important. Horizontal section plane. So is cut by a horizontal section plane parallel to HP at a distance of 15 mm from the top end. Draw the sectional top view and front view. Draw the sectional top view and front view. Not simply simply top view. Sectional top view. Draw the sectional top view and front view. Okay. So yes, tell me what is the top view here? Here what is the
It's a square.
yes, okay, draw a square. Yes, draw a square of draw a square of dimension. What is the dimension here? 40.
40 by 40.
Yes, 40 by 40. Okay, so draw a square of side 40 by 40. So this is my top view. Okay, then name the square. Okay, name the cube. See, I will name this as this point as so this as A, B, C, D. Okay, A, B, C, D, and here this point I will name P, Q, R, and S. Yes, I will name this point as A bracket P, okay, A bracket P, then this one B bracket Q, C bracket R, D bracket S, okay, A, B, C, D and P, Q, R, S, okay. Then what is the front view? What is the shape of the front view? Yeah.
It's a square
Square of height
of 40.
40, okay. So draw a square, okay. Draw a square of height 40. Okay, and name the front view. So here in the front view, A is visible, but D is invisible, right? So A dash bracket D dash. So here A dash bracket D dash. Here B dash bracket C dash. B dash bracket C dash. In the bottom, this point is P dash bracket S dash. Here Q dash bracket R dash. Okay, then next is the cutting plane. Okay, draw the cutting plane. Here the cutting plane is, here what is the name of the cutting plane? What is the name of the cutting plane? It is horizontal section plane, right? Horizontal section plane. What is horizontal section plane? What is
Um, parallel to
HP?
HP and perpendicular to VP.
Yeah, a section plane which is parallel to HP and perpendicular to VP. That is known as horizontal section plane. So what is the front view of horizontal section plane? What is the front view of horizontal section plane?
Yes, straight line.
It's a straight line. Okay. So draw a straight line in the front view. Draw a straight line in the front view. Okay. Draw a straight line in the front view. How much distance from the top end? Top end?
15 millimeters.
Yeah, 15 millimeter. Okay. So the distance between the top end and the cutting plane is 15 mm, 15 millimeter. So the cutting plane is at a distance of 15 millimeter from the top end. The cutting plane is at a distance of 15 millimeter from the top end. Cutting plane is at a distance of 15 millimeter from the top end. Okay. Then how many cutting points here? How many cutting points?
4.
Yeah. So yeah, here, listen. So this is my cutting plane, right? This is my cutting plane. Okay. This is my cutting plane. And this cutting plane cuts, see here, this edge, this edge, this edge, and this edge. That means here 2 points, here 2 points. But in the front view, you can see that one point is in the front and while the other point is in the back side. In the right side also here, this point is in the front side where this point is in the back side. So I will name this as here 1 dash. Okay, then the another point is back side. Then I will name the next point here, the next visible point, because this is 1, this is 2. I will change the color, then only you can see. Okay, yeah, I will write here 1. Okay, it's not visible. Yeah, this is 1, this is 2, this is 3, this is 4. Can you see that numbers 1, 2, 3, 4 in the 3D view? Yeah, here.
Yes, sir.
Okay, 1, 2, 1, 2 means front side cutting point, where 3, 4 back side cutting points. Is that clear? Is that point clear?
Yes, sir.
Okay. Okay, then I will name 1 dash, 2 dash, then 3 dash here, comma 4 dash. Okay. Then project the cutting point. So you will get 1 here. Very important. This is very, very big. In simple figure, it is not an issue. But in the case of complicated figures like hexagon, pentagon, this concept is very, very important. In this simple cube, very, very easy. Okay. This no need to apply this concept. But in the case of complicated problems like hexagon or pentagon, this is very, very important. Otherwise, you will not get the correct shape, correct section. So very important. Okay, so 1, you will get 1 here. So then here, this is, you will get 2 here. Then this is 3. And finally, this is 4. So join 1, 2, 3, and 4. Okay, join 1, 2, 3, 4. This is your section. Draw 45-degree lines that represents the section. So this is my section. And what is the name of this view? Yeah, here, what is the name of this view?
The orthographic view.
No, this below XY, this view, below XY
Top
line.
view.
Top view, simply top view or sectional top
Or
view?
section top view.
Yeah, okay, right here. Sectional top view, please write. This is known as sectional top view. Okay, and this is known as sectional top view, or it is known as sectional plan. Sectional plan. Sectional top view or sectional plan. This is called a elevation or front view. This is called a elevation or front view. Okay, elevation or front view. Okay, clear? Mark all the dimensions. So here, how many dimensions? Yeah, here.
3.
Two, only two. Where 3? Only 2, right?
The length, the height, and the distance from the top.
Yeah, the height. Here only 2 dimension, right? Dimension means the that values in the question. Only 2. But that means side and that distance. That's it. Okay, so side is 40 mm. Side is 40 mm and distance is 15 mm. Okay, so please mark. Side is 15. That means this distance is 15, and this side is 40. So you can mark this height also, no problem. 40. Okay, clear?
Yes, sir.
Okay. Then the next one I will give homework. Okay. Okay, yeah, here say something about this 3D figure.
It's a triangular prism
Yes, it's a
resting
triangular prism. Okay, correct.
with
Then
one of its rectangular faces resting on HP.
what once again?
One of its rectangular faces resting on HP.
HP. Yes, correct. Okay. Then
Then
what about the cutting plane? What about the cutting plane?
it's it's parallel to HP and perpendicular to VP.
Parallel to HP and perpendicular to VP. Okay.
And it's X millimeters below the top.
No. Here you can see what is the distance
It's 20 millimeters above the base
above
side.
the base, above the HP, right? Above HP, right?
Yes, sir.
Okay. So this is homework. So do this problem as homework. So with that being said, I am ending today's class. So we will do the rest of the problems tomorrow. Okay. Thank you.